Hello everyone. So today we're going to talk about separable equations and what they mean in terms of differential equations. So separable equations are the basic and most simple form of solving a differential equation, which are first order equations with separable variables. So this type of solving involves a lot of integration because you'll be splitting the question into two sides, hence why it's called a separable equation with separable variables. So the basic definition we have is a first order differential equation in the form dy by dx equals g of x and h of y. So you have two functions, one with respect to x and one with respect to y. It's said to be separable or to have separable variables. Well, what does this mean? Essentially, this means that you can separate the variables x and y in a way such that either side is independent and you can integrate each side individually. So I think the best way to understand this is these two examples here. So we'll start on the left here with example number 1, where we have dy by dx equals y squared x e to the 3x plus 4y. So we can ask ourselves this question: is this a separable equation or not? And so here we can see that we can rearrange this equation to look something like this. So we have x times e to the 3x, and remember that this part here can be separated using exponent law. So we have x e to the 3x, and then we have y squared times e to the 4y. So all we're doing is splitting it up and rearranging. And now you can see that we have this part here and we have this part here. So essentially what we have here is g of x and h of y. So we have two distinct functions, one with the variable x and one with the variable y, and therefore we can separate them and solve. So the way we would solve this is by simply dividing both sides by the h of y and multiplying both sides by d of x. So we get d of y over y squared e to the 4y is equal to x e to the 3x dx, right? And so in this way, what we can do is integrate both sides and solve, right? And this would be in the form of, the left side would be in the form of y, right side in the form of x. So if we look to the right here, we'll do another example. Here we can see dy by dx is equal to y plus sine of x. So in this case, you may think, okay, well, we have y here and we have x here, but they're being added, right? So you can see you may have g of x here and h of y here, but how will we separate this so that it's independent on either side, right? How would we do that? And so you could try, maybe dy by dx minus sine x is equal to y, right? But then you have to divide by y, but that means you would get y under the sine, so that doesn't work. So essentially, what this means is that this is not a separable equation. And there is no way of expressing y plus sine of x as a product of the function of x times a function of y, essentially is the idea. And so that is basically what it means to have separable equations, and they're very useful in solving differential equations because you can integrate either side, solve for your variables, and get your final solution.